Ladies and gentlemen, welcome to PolyU. So now we are going to discuss something smelly, something a little bit disgusting, but also something very important. That is the diapers for elderly. You may ask, there's so many options, why you guys choose a diaper? Hope this video can give you
As
some
Hong Kong's
hints.
population ages, a hidden challenge emerges. Seniors grappling with incontinence face more than physical limitations. It is a slow theft of dignity, a persistent health threat, and a quiet agony endured behind closed doors.
For these seniors, incontinence leads to chronic dehydration, skin irritation, and infections. Beyond these daily struggles, it also increases their risk of severe health complications, including urinary tract infections, diabetes, and colorectal cancer. To address this issue, wearable technology offers a promising path. Technology enables early detection and continuously monitoring, giving seniors the care that they deserve with dignity and precision.
Presenting Doc Diaper, a revolutionary smart solution, helping them find back their dignity and health. Equipped with advanced biosensors and smart detachable module, our smart diaper quietly conducts urine tests and feces screening throughout the day. Test results are instantly transmitted to caregivers' phones, complete with real-time alerts, AI-driven insights, and expert recommendations. This isn't just a product, it's a reimagining of elder care, where technology amplifies humanity. We believe dignity and health should never be compromised by age.
As you can see, Hong Kong is becoming one of the most aging society around the world. And according to Hong Kong government, there are 25% of elderly who are suffering from the urinary and fecal incontinence. Incontinence not only decrease their quality of life, but also dramatically increase their risk of developing certain disease. So we're thinking of, can we integrate some kind of a smart and sustainable solution into one of their daily used product? And that's the reason why we choose a diaper for elderly. So meet Doc Diaper. It is a smart diaper capable of monitoring users' health, body condition through continuous urine and fecal tests. The data will be transmitted to the cloud, analyzed with machine learning methods and expert system. At last, some professional suggestion and insight will be presented on a mobile app. And then let's move on to the design of our smart diaper.
So, as you can see, our smart diaper mainly consists of two parts. The first one is a detachable and reusable smart module, and another one is a single-use diaper. The smart module mainly consists of a microcontroller unit, a Bluetooth, and a built-in battery, which will provide power, pre-process the data, and transit to the cloud. The single-use diaper is a three-layer composite structure. You can see the top layer is a breathable linen. It's made of ultra-fine fabric, a non-woven fabric plus a feces detection component, which will gain information from the feces. The absorption layer is made of SAP, super absorbent polymer, with a urine detection component, which is located at the upper half of the layer so that it won't be contaminated and prevent the backflow. The last one is the bottom layer, which is a leak-proof film. It's made of a breathable PE film that will prevent the liquid leakage. So let us explain more about the detection system.
So talking about the detection system, we have two main tests, the urine test and the feces test. And the urine test detects glucose, uric acid, and nitrite levels. And the feces test tests for occult blood in the feces using tetramethylbenzidine. So the urine test works as follows. We have a PET substrate, and silver and carbon is used for the circuit printing. And when uric acid and glucose come into contact with the chemicals, it oxidizes and sends out a current. In the urine test, in the nitrite testing, we have a grease reagent. When it comes into contact with nitrites, it reacts and makes a pink azo dye, and it changes the color intensity of the photodiode, and then this is also detected by the MCU. And the feces test is done using tetramethylbenzidine and cumin hydroperoxide. In the presence of hemoglobin, it forms a blue-green compound, and the color intensity is measured by an optical color sensor. Everything of this is embedded in an electronic system which is reusable and rechargeable. We use a FPCB and a Bluetooth module, which is removable and rechargeable, to send the data to the mobile devices. Now let's take a look at the AI model.
Okay, so Dr. Diaper employ two main patterns to handle with the data collected from the sensors, the real-time data and the long-term data. For the real-time data, we have the isolation forest to detect anomalies, specifically values that exceed their normal range. Here's an example. And for the long-term data, XGBoost is a widely recognized AI model in the field of medical analyzing. Its advantages lies in first ensemble learning, allow it to process multiple features, and overfitting prevention, which is suitable for our small data sets, which may contain like device errors or other noise. At last, its adaptability for fine-tuning is important, because our user personal data will build their personal model, and this will help to enhance the accuracy of prediction and also guidance. All the results obtained from the server will then be presented in our app interface. Let's have a look at it.
So imagine this scenario: your elderly parent or patient wears a smart diaper, and their health data silently streams into a mobile phone. Let's see how our app makes the caregiving proactive. You can also scan the QR code to see more details. So for the real-time monitoring, we transform the raw health data into actionable notifications in a user-friendly way, and within one tap, the real-time alerts appear. And for the long-term sections, we employ the previously mentioned AI models to give early detections. Also, the users can export their health report to their doctors for more advice. Also, customize the notifications and data privacy in the settings. Now, let's move on to the business plan of our product.
Talking about the business plan, we did some market research and we compared Doc Diaper with other products, including traditional diapers, smart diapers, a separate fecal and urine test in the hospitals. So our product is much cheaper, has more functions and more accessible to people. So understanding that the Hong Kong population has around 500,000 of people who has these problems, and understanding that the market penetration is around 12%, we estimate that the revenue after the first year is going to be around 7 million of Hong Kong dollars, and after in 3 years, we're going to do like in 15 million of Hong Kong dollars. After solidifying our presence in Hong Kong, we plan to expand into the mainland China, then to East Asian countries, including both Japan and Korea, and then expand to North American and European countries. Doc Diaper, let's take care of elderly people. Thank you for listening to us.
I have a quick question. Why are you targeting elderly for this instead of targeting for babies? Because parents spend more money on taking care of the baby than adults spend money than taking care of their parents. That's just like, it's sad, but I think that's what market goes, right?
I think there's basically two reasons. First one is because we do some research in the babies, and actually the duration of baby using a diaper is very limited. And also, the second reason is compared to the overall, like the total number of the baby and the total number of the incontinence elderly, it's actually elderly with incontinence have a much more bigger potential market. Yeah, so we're thinking of maybe the elderly with incontinence is the future for the diaper.
Also, I want to add that babies, of course, are really important to our society, to our world, but we do not have to forget about elderly people because the population of elderly people is rising almost in every country, in North America, in Asia, and in Europe, and nobody actually taking that much of care of them. So we propose a solution. We know that population, the market is quite large. We don't have a really competitive competition in the market because mostly people, they try to focus on the baby's diapers, for example, to provide some kind of functions like to detect a wetness, to see like what kind of time like the infant or baby did like something like in a diaper. But nobody's taking care of the elderly people. And by that, we try to promote health, promote more sustainable life, and just make the whole life for conditions for elderly people more livable.
So my question is the level of waste. Actually, can you go back to the slide on the structure, because your reusable component is the component that really powers the detection part, right? Your top layer. So your top layer is actually the one that gets changed every time, and that's the part that's in contact with the urine and feces. However, you're essentially, putting this additional material into the diaper for detecting metrics that can be, frankly, easily detected otherwise. I mean, you kind of know if a diaper needs to get changed, or, things like blood glucose can be monitored by a number of other means. So how do you think about, the waste you're creating here relative to the additional information value add that you're bringing with this technology?
So the thing is, we're trying to make the host sensors, wait a second. So all of these sensors is kind of just like a paper. It's flexible like this. So every sensor is kind of like a traditional diaper with two extra paper inserted into the diaper. So basically, for the single-use part, we didn't add that much pollution for the single-use part. And for the reusable part, we also make it very light. So it consists of two parts, like FPCB. FPCB is a flexible circuit board, and then it's very light as a paper, and also we got yeah. And also we have a battery. Yeah, that's a clean one, of course. Yeah, and also the battery we choose, we also consider the comfortable issues. Maybe we can explain more about the battery part. Yep.
Yeah, the battery we use, hope to use a coin battery, and which is rechargeable. We hope to use lithium polymer batteries, which is used in low energy devices. And the duration of the battery is like 1 day. We can, because the battery works only when it needs to send the data to the mobile device, right? So an average person urinates around like 6 to 8 times per day, and feces, let's say, like maximum thrice or 4 times. So it should be definitely enough. It definitely has enough power to power it for 1 day, and then you can recharge it overnight. So we have, like, it's sustainable.